today? Okay, right. Last class we have completed concentration cells, or no? So there are two types of concentration cells. What are those? Electrode gas concentration, electrolytic concentration cell. Right. In electrode gas concentration cell, what is the relation between P1 and P2? And what is the formula? Relation, very important. So what is the formula? Nernst equation. Log E naught, no, E naught cell equal to 0.0591 by N log P1 by P2 or P2 by P1? P1 by P2, where P1 should be greater than P2. Whereas in case of electrolytic cell, C2 by C1 comes. Same formula, C2 by C1, where C2 should be greater than C1 for spontaneity of the reaction. That's over now. Right, next is batteries and cells and batteries. Cells and batteries. So there are two types of batteries or cells. One, primary cell, secondary cell. Okay, listen. So what are primary cells and what are secondary cells? So primary cell is the cell which is the cell in which once the chemicals are consumed, they cannot be regenerated or recharged by passing the current from external source. Then they are called what? Primary cell. It means primary cell is the cell in which once the chemicals are consumed, those chemicals cannot be recharged, cannot be regenerated by passing the current from external source called primary cell. It means if the primary cell once it is used, you have to throw it. You cannot be reused. Like for example, what are example for dry cell? Dry cell, no? We use in our remote and even wall clock, etc. That is a dry cell. So dry cell also called Lake launch cell, right? Lake launch cell. And there is another example is mercury cell. Or it is also called button cell. Where mercury cell, button cell used? In wristwatches. It's like button like cell will be there, no? Even our mic also, it is a button like cell will be there. It is also button cell, or it is also called mercury cell. So therefore, so these two are example for primary cells. So therefore, primary cell is the cell in which once the chemicals are consumed, it cannot be recharged or they cannot be regenerated by passing the current from external source. Then what about secondary cell? Secondary cell is quite opposite to primary cell. Right, secondary cell is the cell in which once the chemicals are consumed, they can be recharged, they can be regenerated by passing the current from external source, like your mobile battery, right? So mobile battery, once it is discharged, it can recharge, no? Mobile ಬಿಡ್ತೀರಾ ಡಸ್ಟ್ಬಿನಲ್ಲಿ ಬಿಡ್ಸಲ್ಲ, ನೀವು ಬಿಡ್ಸ ಬೇರೆ ಯಾರು ತೊಗೊಂಡು ಹೋಗ್ತಾರೆ, right? It can be recharged, right? Therefore it can be recharged, those chemicals can be reformed by passing the current from external source. Then such kind of cells are called secondary cell. So again there are two secondary cell. There are two secondary cells. Tell me. One is a lead storage battery. Lead storage battery and another is nickel cadmium cell. So lead storage battery, nickel cadmium cell, these two are example for secondary cell. Okay, so other than this we have another cell is hydrogen oxygen cell, that is called fuel cell. So where fuel is used to get the energy, that is electric current, fuel cell. Okay, then next we have corrosion and its applications. Okay, right, first here cells and batteries. One, right, primary cell. Madam kottu bare fill madkonante. Primary cell, the cell in which once the chemicals are consumed, the cell in which once the chemicals are consumed, they can be recharged. No, sorry, they cannot be. The cells in which once the chemicals are consumed, they cannot be recharged. They can be recharged. So cannot be recharged by passing the current from external source. By passing the current from external source. Called primary cell. External source in opposite direction. Passing the current from external source in opposite direction called primary cell. Example example, dry cell, Leclanche cell. One more is mercury cell or button cell. Next, secondary cell. Secondary cell, the cell in which once the chemicals are consumed, the cell in which once the chemicals are consumed, they can be recharged and regenerated. They can be recharged and regenerated by passing the current from external source. By passing the current from external source called secondary cells. Example, lead storage battery, nickel cadmium cell. Lead storage battery, nickel cadmium cell. Okay. Right, first right, next right, primary cell. Example, dry cell. See here in our cell bus we have all 4 cells. In all 4 cells again important is only 3 points. 1, what is the anode, reaction at anode. 2, what is cathode, reaction at cathode, cell reaction. And what is the cell potential. Anode, cathode, electrolyte, cell reaction is it. These points to be remembered. Okay. So take example, first one, dry cell. Dry cell. Tell me. Listen. So what is dry cell? Here in dry cell, what are the cathode, anode and cell reaction? See, dry cell consists of a cylindrical vessel. Listen first. It is consist of a like cylindrical vessel and which is made up of zinc. Therefore zinc, yeah, dry cell consists of a cylindrical vessel which is made up of zinc, and a middle of the container, and a graphite rod is placed middle of the container. There is a graphite rod, right, it is a graphite rod. So this graphite rod placed in a middle of the container which is act as a cathode. This is a anode. Zinc rod is a anode, it is a cathode, and this zinc rod is surrounded by manganese oxide MnO2 and carbon powder. This is a MnO2 plus carbon powder. Okay, then this graphite rod is surrounded by these two. Next, in between cathode and anode there is a electrolyte will be filled here. Here what is electrolyte? In this electrolyte is the mixture of MnO2 plus ammonium chloride. It is a electrolyte, and this cell produces approximately cell potential. It is 1.50 volt electric current. Okay, now tell me. So this is the what is it? Leclan cell, dry cell. Okay, so a dry cell consists of cylindrical vessel, a zinc cylindrical vessel which is act as a anode, and a graphite rod is placed middle of the container and which is surrounded by zinc oxide and copper and carbon powder which is act as a what? Cathode. This is a cathode, and the mixture of MnO2 and ammonium chloride, it is actually paste. The paste of MnO2 and ammonium chloride taken in between cathode and anode, this is what? Electrolyte. Then now what is the reaction at anode and cathode takes place? Let's see reaction at anode. Tell me here, which is anode here? Zinc. So at anode which reaction takes place? Very good. Therefore what is oxidation? Zinc gives rise to zinc plus 2 electron. This is the oxidation only. Next, reaction at cathode. So which is cathode taken here? Cathode is, it is a graphite rod, but I told you graphite rod is a inert electrode. Yes or no? Graphite and platinum are inert electrode, they do not involved in the reaction. But now which is the electrolyte? MnO2 plus ammonium chloride. Therefore now MnO2 involved in the reaction. MnO2 plus ammonium chloride. In ammonium chloride, ammonium ion take part in the reaction. Therefore now tell me, one manganese, one oxygen and one hydrogen, it forms MnOH or MnO and OH. Say one oxygen left as it is and one more oxygen plus one hydrogen. Okay, one positive and negative, neutral. Then what is left here? Ammonia will be left now. In ammonium, so one take one hydrogen, one oxygen, one OH, and what is left? Ammonia. Therefore at cathode this reaction takes place. But at anode how many electrons are releasing? 2. At cathode 1 electron is involving, therefore multiply with 2. Therefore now what is the cell reaction? So cell reaction is so 2 electron cancel, then zinc plus, tell me, 2 MnO O2 plus 2 ammonium ion plus or gives rise to zinc plus 2 plus 2 MnO OH plus 2 ammonia is formed. Okay, next, in above reaction zinc plus 2 and ammonia is formed, but we know that zinc plus 2 is more reactive towards ammonia, so it reacts with 4 ammonia, it forms the complex zinc plus 2 ammonia 4 ammonia, it gives us to ammonia complex compound, and this cell produces cell potential equal to 1.51 volt. Okay, so here important is what is anode, what is cathode, what is electrolyte, and these reactions, only this much. Okay, ready? Take the rough diagram. Diagram also not required, if you take you can, easy to understand. Right. Dry cell consists of cylindrical zinc vessel. A dry cell consists of cylindrical zinc vessel, act as a anode. Cylindrical zinc vessel act as a anode, comma, a graphite rod is placed middle of the container. A graphite rod is placed middle of the container and it is surrounded by ZnO2 and carbon powder. ZnO2 and carbon powder. MnO2 carbon powder act as surrounded by MnO2 carbon powder act as cathode, comma, a paste of MnO2 and ammonium chloride, a paste of MnO2 and ammonium chloride taken between cathode and anode, which is act as what? Electrolyte. Which is act as electrolyte. Okay. Then take reaction at anode, cathode, cell reaction, cell potential. Okay. Next, right? Mercury cell or button cell. Okay, so mercury cell, it is button cell, mercury cell will be like this. Okay, if you cut it, you can right, see, right, mercury cell. In mercury cell, zinc amalgam, zinc plus mercury is act as a anode, and here cathode is mercuric oxide, HgO, it is a cathode, and the mixture of zinc oxide and KOH is a electrolyte. Okay, only these things to be remembered. You must remember, even board exam also they ask equation or cathode anode only. Then what is the reaction at anode? See, at anode, which is anode here? Zinc plus zinc mercury, zinc amalgam. Therefore here zinc amalgam, okay, it is, now it is connected to electrolyte. In electrolyte there is zinc oxide, no, right? Now tell me here, at anode which reaction takes place? Oxidation, means electron, loss of electron, no? In order to loss of electron, zinc amalgam, it is contact with OH minus, because where zinc converts into zinc plus oxygen, you will get zinc oxide, ZnO, okay, and mercury, it is deposited as a Hg only. Then now take here 2 OH minus, tell me, 1 oxygen taken, what is oxygen here left here? 1 oxygen, 2 hydrogen, tell me 1 oxygen, 2 hydrogen, it becomes H2O, plus how many electron? 2 into OH minus, to balance 2 electron taken. It means at anode, zinc amalgam converts into zinc oxide, as well as mercury is formed, water to electron, it is oxidation. Next, what is the reaction at cathode? So here, what is the cathode reduction takes place? So which is the cathode here? Zinc, mercuric oxide, HgO. So here HgO again converts into Hg. Mercury has to be deposited. Mercuric oxide converts into mercury. Tell me, to convert mercuric oxide into mercury, and moreover it is a gain of electron. Electron has to be gained. To gain electron, there is a water is liberated here. That water react with here. Therefore, tell me. So here, how many oxygen? 1, 2. How many hydrogen? 2. 2 hydrogen, 2 oxygen. 2 OH minus can be formed, no? Okay. Then there is a 2 into minus. 2 minus means how many electron? 2 electron. Balanced or not? It means mercuric oxide converts into mercury, and by taking water, it converts into OH minus. That OH minus again involved here. Okay. Therefore, in first equation, there are 2 electrons are losing, here gaining 2 electron. Therefore, balance the equation. It already balanced with respect to electron. Then what is the cell reaction? Cell reaction is zinc amalgam reacts with 2 OH, here is 2 OH, and HgO plus water, here also 1 water molecule, then gives rise to zinc oxide plus mercury, 2 mercury formed. Then what is the cell potential of this reaction? E cell equal to, it is approximately 1.35 volt. Take down. So equations you should remember as it is. Next is secondary cell. Bardira bega barri. Okay, next is secondary cell. In secondary cell, what is the first example? Lead storage battery. Read on. First example is lead storage battery. Lead storage battery. Okay, so tell me, lead storage battery, nickel cadmium cell, these two are example for secondary cell. In secondary cell, once the chemicals are consumed, they can be regenerated, right? And cell can be recharged by passing the current from external source in opposite direction. So such cells are called secondary cell. Okay, so you might have seen even like cells like dry cell, there will be a secondary cell, rechargeable cells. Okay, here this is a best example, lead storage battery, where we used lead storage battery in all UPS, in home UPS, even in our automobile vehicles, two-wheeler, four-wheeler vehicle, which has lead storage battery only. Okay, yes or no? Sulfuric acid will be added here. Therefore, let's see what are the cathode, anode and electrolyte. First one is anode. So what is the anode in this? So anode is spongy lead. It is a lead only, but which is having holes like sponge like lead, which is called a spongy lead. And cathode is lead oxide, PbO2. Like here, what is the cathode here? Mercuric oxide. No, in mercury cell, mercuric oxide. In lead cell, lead oxide, PbO2. And what is electrolyte? Electrolyte is, it is a 38% sulfuric acid, H2SO4. Then now, since it is a secondary cell, there are two type of reaction takes place. One, reaction during the cell discharge. When the cell discharge, when current is drawn, right? When current is drawn from the cell, it is cell discharge. Next, reactions during the cell recharge. When can be cell recharge? When current is passed from external source opposite direction. That's what you try to remember. One reaction, other reaction is quite opposite. That's what. Let's say reactions during the, right on, reactions during cell discharge. So that is when cell is discharged, current drawn from cell. No, when current is drawn from the cell, cell is discharged. Okay, when cell is discharged, what is the reaction at anode and reaction at cathode? Cell reaction. Come on, tell me. First one, reaction at anode. Which is anode here? Sponge lead. Lead only, sponge lead. That is a Pb. So lead is a anode. Then that lead is placed in where? Sulfuric acid. Right. Therefore, it is a Pb lead plus in sulfuric acid there is a sulfate ion. No? And remember, in lead storage battery, lead finally converts into lead sulfate. Okay, even at cathode and anode, both at cathode and anode, lead has to convert into lead sulfate during the cell discharge. Therefore, Pb plus SO4 minus 2, what do you get? First Pb has to convert into Pb plus 2. Then Pb plus 2 plus SO4 minus 2, what do you get? Pb SO4 plus, when Pb has converted into Pb plus 2, there are 2 electrons are lost. That is oxidation. Simple reaction. Next is cathode, PbO2. Now tell me, PbO2 cathode, but PbO2 also converts into what? PbSO4 only. Now tell me, in order to convert PbO2 to PbSO4, what should be removed? 2 oxygen. In order to remove 2 oxygen, how many H plus required? 4 H plus, because H plus is available, sulfuric acid. Right, when you take 4 H plus, how many electrons should be added? 4 electron to get neutral. 4 positive, 4 negative. Okay, then Pb and of course SO4. SO4 required, no? SO4. Now, which gives rise to, tell me. Now first Pb, no? This Pb plus 2, SO4 minus 2. What do you get? Pb SO4. And 2 oxygen, 4 H plus. 2 H2O plus. What is left here? That's it, no? Balanced, no? Balanced. Now, in above equation, 2 electrons lost, here 2 electrons gained. No, 4 electron gained. That's what, multiply with 2. Then write the cell reaction. 4 electron, come on, tell me. It is a 2 Pb plus, it is 4 plus, it is how many? Here 2 plus 1, 3. 3 SO4 minus 2 plus 4 H plus gives rise to. So here 2 plus 1, 3 Pb SO4 plus how many water molecule? 2 water molecule. Okay, so this is the Pb. O2 is left now. Okay, PbO2 has to come here plus PbO2. Right, now this is the reaction during the cell discharge when current is drawn. Now what is the reaction during the cell recharge? Cell recharge, it is exactly opposite. So here the product is PbSO4 plus 2H2O, no? Now it reactant becomes PbSO4 plus 2H2O gives rise to. Now here reactants are this, it become no product. It means product converts into reactant in order to get again, that is current from the cell reaction. So therefore 2 Pb plus 3 SO4 minus 2 plus 4 H plus plus PbO2. Take it down. So here the cell potential is approximately 2.05 volt.